Hi guys, welcome back to the channel. So today we are going to discuss a backtracking problem. The problem is maximal string. It's a very good problem, right? Let's see what the problem is. Given a string A and an integer B, what is the maximal lexicographical string that can be made from A if you can do at most B swaps, right? If we can do at most B swaps, we need to find out what is the maximum lexicographical string that can be made. What does that mean? So let's see what does that mean. Let's take this test case first. 254, right? We are given a string like 254 and we are given an integer b which is 1. That means we can like do at most one swap. So if we swap 5 with 2, we will get 524 and it is a like bigger number than 254. So this could be our answer, right? Also we can make we can swap 4 and 2 also. We can like swap 4 and 2, so it will make 452, but 524 is greater than 452, right? So this will be our answer. We have to return the maximal lexicographical string that can be made, right? Now let's see this example, this test case. In this test case, we are given again the same string 254, but this time the like b is 2. That means we can do at most two swaps. Either we can do one swap if that gives us the the larger number, or we can do at most two swaps, right? We have to return the the maximum lexicographical string. So what we can do in this is we can do at most two swaps, right? So we can swap 2 with 5, so it will give us 5 2 4, and then we can swap 2 with 4, so it will give us 5 4 2, right? So we are doing one swap over here, and then we are doing two second swap over here, so at most two swaps, and the largest number which can be made is 542. So the output is 542, right? So it's a very easy problem, right? It's you'll learn after solving this problem, you will get to know why and how we can use backtracking, right? Let's see. We'll be taking this test case. So let's see how we can do this. Now if you see, like, we have a our input 254, how we'll approach it, how we'll approach the problem. Now if you read the question, we have to generate the maximum lexicographical string that can be made from A if you do at most B swaps, right? And now the one question which comes into mind, right, that how will I know that what swap I can do? Like, I can swap this also, I can swap these also, or I can swap this also. So when you get this thing in your mind, you can like assume that we have to consider we have to consider all possibilities, right? We have to consider all possibilities. So for considering all possibilities, the second thing which comes into mind is recursion. Because using recursion, we can make all the possibilities, right? We can consider all possibilities. So we'll be using recursion. Let's see how. So first of all, suppose let me do indexing 0, 1, and 2. So I'm thinking that I want to swap this index, right? I'll swap this index with this also. I'll swap this index with this also, right? So what, and also I can do this. I can swap this index with this, or this index with this, right? Or I can do is I can swap this index with this, or this index with this. So what are you getting with this? Like, are you like, don't you think that if we have to do something like this, we need to have double loop, like two for loops? We will require two for loops, na? Because one for loop will go over to each index, and the other for loop, like if we are at this index, other for loop will swap it with this and swap it with this, right? So what we'll do is we'll have two for loops. Let's see how. We have 254, right? And we have b as 2, right? So now see what we'll do is, first of all, This is indexing 0 1 2. I will consider this. I want to swap this 0th index. So what one case could be, I swap this 2 with 5. That means I'm swapping these two indexes. So it will become 5 2 4, right? And I have done one swap, so total number of swaps which are left is 1, right? I have done one swap, so 1 is left. Now what also I can do is, now when I'm over here, what I can do is I can swap this with this, or I can swap this with this, right? So after this also, what two cases will become? There will be two cases. 5 could be swapped with 2, 2 5 4, which is again this thing, or I can swap 5 with 4, so it will be 4 2 5, right? And now the swaps will be 0. So we will have an answer string, right? We'll have an answer string which will be initially empty. We will compare if this number is greater than answer string, we will update it with that number, right? And this, if this is like 425 is greater, so the answer will be 425, right? As of now, right? Now what we can do is, now we'll go back, right? We'll go back. So basically, for going back, what we'll do is we will backtrack. How backtrack? For example, over here we swapped 5 with 4, so as to get this 425. Now we will again swap 5 with 4 so that we can get again this thing, right? So first of all we did a swap to get this. Now in order to go back, we'll again swap so that we can get this, right? And now earlier what we did was we swapped 2 with 5. Now we'll swap 2 with 4. So to again get this string, what we'll do is we swap 2 with 5. Now we'll backtrack, we will swap again these two, so that 5 and 2, so that we can get this 2 5 4 again. And now when I'm again at this position, I will swap 2 with 4. In this part I swap 2 with 5. Now I'll swap 2 with 4. So when I'm swapping 2 with 4, I will get 4 5 and 2 this. Now what I can do is I can swap 4 with 5, or I can swap 4 with 2. So if I swap 4 with 5, I'll get 5 4 2, and if I swap 4 with 2, I will get 2 5 4. Now 542 is greater than 425, so now this will be updated and 542 will be in the answer string, right? And then for backtracking, what we'll do is, we are at this position 254, I want to backtrack. So earlier what I did was I swapped 4 with 2. Now again I will swap 2 with 4, so 2 with 4 will again become 452. And then if I have to make this, I swap 2 with 4, so over here I'll swap these and these again, and I'll get this string again, right? Now similarly you can make the recursive tree in which you are swapping this 5. What we were doing in these two cases, in this case and in this case, we swap 2 with 5 and 2 with 4, right? That is 0 index. Now you can do is what, you can swap this with this first, so it will become 5 2 4, and then you can swap 5 with this, so it will become 2 4 5, and again you can do again. So this will be like a recursive tree, right? So this is how you approach this problem, right? You take all the possibilities and then you find out the maximum at the end. Like when b is 0, then when we cannot like make any swaps, then you can get the maximum. And at each point over here also you need to compare it with the answer, because over in the question it is given at most 2 swaps, right? We can do either one swap or we can do at most 2 swaps. It's not necessary that we have to do 2 swaps, right? We can get answer at this place also. So at each point over here also, when you are doing one swap, you need to compare it with the answer, right? And yeah, so basically this is the approach. So let's see what we are doing. What we are doing is, we know that if we have 254, we have to compare, we have to swap 2 with this also, 2 with this also, or we can do is we have to swap this with this also, 5 with this also, or 4 with 2 also, and 4 with 5 also, right? All these cases we need to take care of. So we will have two loops, 0 to n, and the other one will start from um, j, will start from I to n, right? And then what we can do is we can swap it, swap, and then we can do recursive call to b minus 1, and then we'll again backtrack. For backtracking, we'll again swap, right? So this will be our logic. Let's see the code once. So see, in the code what we are doing is we have taken an answer string. It's a global string, right? Then what we are doing is we are have made a function in which we are passing this string and the b and the integer b, right? And at the end we are returning the answer. So let's see what is in the find function. If this is k, right? If k is 0, right, which means we have done all the swaps, like we are at this point, then we just need to compare this string with the answer string. So if the current a string is greater than the answer, then update the answer and return, right? And otherwise what we need to do is for int I is equal to 0, I plus plus, we'll be swapping this current position with all the positions. Like we are swapping, if we have let's say if we have like 254, then first of all at here we will be swapping this and this. Then when we are at this, we'll be swapping it with this, and at this we are don't have any further element, so we'll not be swapping it, right? So this will take all the cases, right? And then we are swapping the current a of I and a of j. We again call the recursive function, passing k minus 1, right? And then in order to make this a string again the same, we are again swapping it, right? So just try run this algorithm once, right? Try run the code, you'll understand how it's actually working. Make the whole recursive tree, right? So I hope this video was helpful. If the video was helpful, please like it, subscribe to the channel. I'll meet you in the next backtracking video. Bye.